Hello, welcome back to From X to Integration, your complete math journey from start to finish. So today we're going to be talking about functions. But before we talk about functions, let me ask you something. Say you walk up to a vending machine and you press B3. What do you expect to happen? Let's take a look at this vending machine. When I select B1, I'm going to get different output. When I select B2, I'm also going to get different and as well as B3. So this vending machine is broken because when we click B1, B2 or B3, we're not sure what we'll get. Let's take a look at this second vending machine. I select A1 and I know I'm going to get chocolate. I select A2 and I know exactly what I'm going to get. So all inputs give me one output. You expect one thing to drop, not two things, not sometimes one thing, sometimes another. I know exactly what specific thing I'm going to get when I select a specific output, or rather a specific input every single time. So therefore, this vending machine is a function, and by the end of this video you're going to understand exactly what that means, and you'll also be able to identify a function in three different ways. Okay, let's start with a relation. A relation is just any pairing of inputs and outputs. No rules, no restrictions. Any input can give you any output. So remember that broken vending machine? It's not a function, but it's a relation. Now let's take a look at this ordered pair. Can we see that input 1 gives us output 2, but input 1 also gives us output 5? That's fine for a relation because relations don't care. However, this is not fine for a function because a function has one rule, and the rule is that each input has to give you exactly one output. Always, every time, no exceptions. But 1 is giving us two different outputs, so this ordered pair would not be a function. So it's a relation, but it's not a function. Think about it. If you pressed B3 and sometimes got chips, or sometimes got a sandwich, or sometimes you got nothing, you would say that that vending machine is broken, correct? And so that's the same thing. You would say that it's not a function because a function is a machine that works correctly every single time. So a function is a relation where every input has exactly one output. Write this down. This definition is everything. Input has exactly one output. Now that we know what a function is, let's name the parts of a function. So the domain is every possible input, every value that you're allowed to put in. So going back to the vending machine, the domain is every button that actually works. So B1, B2, B3, A1, A2, A3. Because these are valid inputs, right? The range is every possible output, every value that can actually come out. So chocolate, soda, and all of that. The range is everything that's actually in the machine, right? So what are our possible outputs? Chocolate, soda, popcorn, candy, juice, pretzel, right? So this would be in our range. The range is everything that's actually in the machine, not every item in existence, just what this specific machine has. So waffles is not in this machine, pancakes is not in this machine, so it would not be in the range. So yes, domain is all valid inputs and range is all possible outputs. So from this other pair, my domain is going to be all my possible inputs, which is 1, 2, and 3. And my range is going to be all my possible outputs, which is 3, 5, and 7. So domain are your x values and range are your y values. Simple as that. This is the section with the most exam weight, so pay attention. There are three ways you'll be asked to check if something is a function. You'd be asked through ordered pairs, graphs, and equations. So let's go through each one of them one by one. So the first method is looking at ordered pairs. With other pairs, what you're looking at is your x values, and you're checking if any x values appear more than once. If it appears more than once, then it's not a function because it means that we could get multiple outputs when we click that input in the vending machine. Let's take a look at this set. Is it a function? Input 1 gives output 2 and input 1 gives output 6. So repeating inputs. Input 1 is giving us 2 different outputs, so it's not a function. Now let's take a look at this set. Is it a function? Every x value appears exactly once. One input, one output each time. So then, it's a function. For graphs, we use the vertical line test. The rule is simple. If you can draw a vertical line anywhere on the graph and it hits the graph at more than one point, then it's not a function. Let's take a look at this parabola. No matter where I draw a vertical line, it's going to hit the curve at only one point, so then it's a function since it passes the vertical line test. What about this circle? Is it a function? Once again, we're going to look at a vertical line. If I draw a vertical line, it's hitting it at more than one point, so therefore it's not a function because one x value is going to give us two y values. Think about the vending machine. If we press B3 and two things dropped out, then we would say that it's a broken machine. What about when you're given equations? How can you tell if the equation is a function or not? A good rule of thumb is to check the exponent of y. If the exponent of y is even, then it's not a function. And if the exponent of y is odd, then it's a function. Let's take a look at this example. What is the exponent of y in this example? So, what's the exponent of y for this function? As we can see, the exponent of y is 2, which is even, so therefore, it's not a function. What about this equation? What's the exponent of y? The exponent of y here is 1, which is odd, so therefore, it's a function. This is where most students get confused. There are two completely different questions involving function notation, and mixing them up will cost you marks. So let's look at both of them separately. So how do we solve this question? F of 3 means when we plug 3 in as our input, what comes out? So let's go ahead and do the substitution together. We're replacing x with 3. So now f of 3 is 2 times 3, which is 6 plus 1, and that becomes 7. So this means that when we press button 3 on the vending machine, what drops out? 7 drops out. Since 3 is inside the parentheses, it's the input, and we're finding the output, the thing that comes out. So now let's take a look at this second problem. Now do we see that 3 is not inside, but it's outside, so it's the output. F of x equals 3 means what input will give me an output of 3? It's now asking me which button did I press to get 3. The output is 3 and I'm trying to find the input. So let's go ahead and do it. So 2x plus 1 is equal to 3 because 3 is going to be an output, so it's going to stay outside. And now we have to solve for x. So we're going to take 1 and subtract it from both sides of our equation. So 2x is equal to 2. And then we're going to divide both sides by 2, and our x is equal to 1. This means that input 1 gives me output 3. Okay, let's do a side-by-side comparison. Okay, so for this question, f of 3 is what we're trying to find. And as you can see, 3 is inside the parentheses, so we're given the input. Whereas for this one, we're given f of x equals 3, but here 3 is outside and we're being asked to find the output. So these are completely different questions. Even though the notations look similar, the questions are different, and a lot of students get confused. So I hope that this clarifies it. If it's inside the parentheses, it's an input, and if it's outside the parentheses, it's an output. Let's do one more example just to make everything click together. F of negative 2 is negative 2 input or output. Since it's inside the parentheses, it's going to be an input, which means it's going to replace x. So let's do that. So now it's going to be f of not x anymore, but negative 2 equals 3, not x, but negative 2 plus 8, which is negative 6 plus 8, which is equal to 2. So f of negative 2 is equal to 2. Let's look at the other side of this. Now we're given f of x equals 9. Is 9 an input or an output? As we can see, 9 is outside, so it's an output, which means it's going to stay outside. So we're going to leave it as 9, but now we're going to put 3x plus 8. And now we just need to solve for x. So 8 is going to move to the other side. So it's going to be 9 minus 8, which is 1. And then we're going to divide both sides by 3. And our x is just going to be equal to 1/3. So our x is equal to 1/3, which means that this input, when I press it, gives me 9 as my output, the thing that comes out. Okay, this is the last concept in this video, and this one builds on everything that we just covered. A regular function says every input gives me exactly one output, but a one-to-one function takes it even further. So it says every input has one output and every output comes from exactly one input. So there's no sharing in either direction. Let's take a look at the graph on the right? So for this function, input 1 gives output A, input 2 gives output B, input 3 gives output C, and input 4 gives output D. Every output has only one input, so this is a one-to-one function. Whereas if we take a look at the one on the left, input 1 gives output A and input 2 also gives output A as well. It's still a function because no input gives two outputs, right? No repeated input. So it's still a function, but it's not one-to-one because output A now comes from two different inputs. So not one-to-one, but still a function. Now let's talk about the ways that you can identify if a function is one-to-one or not. The first method is just looking at your ordered pairs, and you want there to be no repeating x, but you also want there to be no repeating y's. So we want to identify if this set is one-to-one or not. The first thing we need to do is to check first if it's a function. And for it to be a function, we can't have any repeating inputs. There are no repeating inputs, so yes, it is a function. Now that we've identified that it's a function, we also want to check whether it's one-to-one. Are there any repeating outputs? And as you can see, the output 2 is repeating, so therefore it's not one-to-one. So this is a function, but it's not a one-to-one function. What about when you're given a graph? How do you identify if a graph is one-to-one or not? You have to check if it passes the horizontal line test, which means that if you draw an horizontal line and it touches it at exactly one point, then it's one-to-one. If it's more than one, then it's not one-to-one function. So we have to first check if it passes the vertical line tests. And as you can see, this graph passes the vertical line test, so it is a function. And now we need to check if it passes the horizontal line test to see if it's one-to-one. And as you can see, this horizontal line is hitting the graph twice, and so it does not pass the horizontal line test, and therefore it's not one-to-one. So summary, a function is a relation where every input has exactly one output, and the domain is your inputs and range is your outputs. And so if you're given functions in other pairs, all you need to check is if x repeats. And if you're given a graph, you want to check the vertical line tests. And if you're given equations, you want to check the power of y. If it's even, it's not a function. And if it's odd, it's a function. But then when you are given function notations, you have to remember that f of 3 is input and you want to find the output, whereas f of x equals 3 is output and you want to find the input. Even though they look similar, they are not asking for the same thing. And then the last thing is one-to-one functions, and in this situation we can have sharing in either direction. So Tuesday we're going to be covering domain restrictions. We're going to be talking about what values are not allowed as inputs and how to write domain using interval notation. So subscribe so you don't miss it. I'll see you in the next one. Bye.